Okay, in lesson 8.4, we're going to extend this idea of proof that you were doing in 8.3, just like when we were proving congruent triangles, and after we learned how to prove congruent triangles, we used if triangles are congruent, then corresponding parts are congruent. Well, that's sort of what we're going to do today with similarity. Once we prove triangles similar, we know by definition that there are some properties from similar triangles that we can employ. So our targets are: I can apply the concept of similarity to establish congruence of angles. I can apply the concept of similarity to establish proportion of segments. So this should sound familiar because when we talked about the definition of similarity, we said angles are congruent and sides are proportional. And then it says I can set up and apply the concept of similarity to solve shadow problems. So that's kind of a unique problem that we're also going to review today. So we're going to do something with proof a little bit, extending the idea of similar triangles, and then talk about these shadow problems. So let's review real quick. You can see from the targets, we've talked about this. We know if, you had this on a previous page, if polygons are similar, then two things are true. One, corresponding angles are congruent, and two, corresponding sides are proportional. Okay, and we won't go through the example again. We have talked about this enough. So I wrote it out for you again here, what we just talked about. Once we have proved triangles similar by one of those reasons, we can use this definition to get congruent angles or proportional sides, and we're going to do a lot with proportional sides. So if you look at the prove here in this is kind of what your proof statements are going to look like today. They're going to be ratios, and so the first thing you'd want to do is find out where those are. So here's AB, and here's AF, and here's DE, and here's FE. And as soon as I do that, I can quickly see the triangles I want, right? If I kind of close this off, those are the sides of these two triangles. So if I can get those triangles similar, I can say the ratio of these sides are proportional. So I have ABCD is a parallelogram. That's given. Right? We know to get triangles similar, we usually want to get angles. So think, what in a parallelogram helps me get angles? Well, hopefully you're thinking parallel sides. So AB would be parallel to DE, and AD, I don't know if we need both, is parallel to BC. If parallelogram, then opposite sides are parallel. All right, I'm looking at some Z's here. I see one right here. Right, that gets me those two angles congruent. That would be angle BAF congruent to angle DEF. If parallel, then alternate interior angles are congruent. I see another Z right here. Right, which means those two angles are congruent. Angle ABF congruent to angle EDF, and that is also, I should just cross that number 4 out, that's also by 3. Those are also alternate interior angles. But now I have two angles in this triangle, congruent to two angles in this triangle. Make sure you get your points matched up correctly. So if I say ABF, that's similar to A corresponds to E, B corresponds to D, and then F goes with itself. That's angle-angle similarity. That's what we were doing up through yesterday. Now we extend it one more step. If my triangles are similar, look at what we know, corresponding sides are proportional. These sides are the sides of those triangles. So then I can say AB over AF equals DE over FE. If triangle similar, then sides are proportional. Okay, so it's sort of like that extra corresponding parts step for congruent triangles. This is what we do for similar triangles. Let's try a few more. All right, we're going to skip 2 because it's very similar to the one we just did, so we're going to jump ahead to 3. You can go back and try 2 on your own sometime if you like. So first thing I always want to do is highlight where these ratios are so I know what triangles I want. There's AD, and there's AB, And where's RW? That's right here, and RS. So as soon as I do that, I know which triangles I want. I want those two green triangles. Those are the ones I need similar in order to get these ratios. All right, because there are a lot of other triangles in that picture. So I'm given triangle ABC similar to triangle RST. Those are the big ones. So I have this big triangle similar to this big triangle. AD bisects angle BAC, and RW bisects angle SRT. That should be ringing a bell, right? If I have bisect and bisect, I should be thinking multiplication maybe, or division. Let's see how that goes. I'm going after the green triangles. Well, ABC is this big black one right here, and RST is this big black one. I see that they share an angle with the green ones. Couldn't I get angle B congruent to angle S? Angle B congruent to angle S. That's from these similar triangles. So the black ones. If triangles are similar, then corresponding angles are congruent. So I have those congruent. Well, I'm going to also grab these at the top, this guy and this guy. So I'm going to add that in there. That would be angle BAC congruent to angle SRT. And I want you to think why I'd want those. Those are also part of the black ones. And if those triangles are similar, those corresponding angles are congruent. Think about those and think about this. All right? I've got a bisector here and a bisector here. I have two bisectors, and now I have the bigs congruent. So if I have the bigs and two bisectors, I should be able to get the littles. So hopefully you realize that's this angle, BAD, and this angle, SRW. So angle BAD is congruent to angle SRW, because if angles congruent, then like divisions are congruent, because I'm going from big to small. But now I have two angles in this green one matching two angles in that green one. So now I have triangle BAD congruent, or not congruent, similar to triangle SRW by angle-angle similarity. So to review, I took this angle from the black triangles. I also took the whole top one from the black triangles, but I used these bisects to get the halves congruent, which were in the green triangles. Once those triangles are similar, again, that's what we did in the previous lesson. Now I can extend it one more step here, and I can say AD is to AB as RW is to RS. If triangles are similar, then corresponding sides are proportional. Okay? All right, here's an example of the shadow problem that was in those targets. You see a lot of these. They're also popular standardized test questions. All right, it says, while strolling one morning to get a little sun, Judy noticed that a 20-meter flagpole, all right, so here's my ground. Let's put a 20-meter flagpole here. 20 meters, cast a 25-meter shadow. So that means here's my shadow on the ground, 25-meter shadow. And the sun's in the sky, right? Shining down, and here's where it hits the ground at the tip of that shadow. Nearby was a telephone pole. So now let's mark this telephone pole. That casts a 35-meter shadow. 35-meter shadow. How tall was the telephone pole? Sun's rays should be coming in at the same angle, right? So because the sun should be at the same angle, these angles should be congruent, which means these triangles are similar. So I can set up ratios. I can say 20 corresponds to X, as 25 corresponds to 35. If I cross multiply and solve, that 700 equals 25x, and if you divide, you get 28 equals x, and that would be 28 meters. So that's an example of a shadow problem. You're going to get more to practice in the notes, and they can do some variations on them. So that's just kind of a starting point for you. But make yourself some good pictures and know that we're looking at similar triangles, understanding that the sun's rays are coming in at the same angle. So these angles would be the same as with these right angles. All right, I want to do a couple more here, or actually just we'll do example 6, which is this one in the middle. It has a nice little twist on it, so let's just do this one. We have YSTW is a parallelogram, and then we have these perpendiculars, which we know will get us right angles. Now look at the proof. What the heck? Right? This doesn't look like ratios to me, but if you peek up here, what would happen if I cross-multiplied a ratio? If I cross-multiplied a ratio, wouldn't it look something like this? So this guy right here is really just a ratio multiplied out. I'm going to write that here, a ratio multiplied out. So I'm going to do the same thing. I'm going to find where those sides are. SX, that's this one. YW, where is that? YW, that's this one. SV is this one, and WT is this one. Well, now it gets even more confusing because those sides aren't in triangles. I very much like the SX and the SV because they're a part of these two triangles, but what about these other pieces? So I've got these all marked in green here. But wow, I don't like this YW. And I don't like this WT because these sides are really not in triangles. I want you to look at that first piece of given, right? The first piece of given is that this is a parallelogram. So what do you know about YW? Isn't it the same as ST? So I'm going to highlight that in yellow. And what do I know about WT? Isn't it the same as YS? So these guys right here, although not in the triangles, have direct links to pieces that are in the triangle. So let's keep those connections there in our picture so we know where we're going after. I still want these two triangles. So I'm going to use this right angle from the perpendicular and this right angle from the perpendicular. That is YXS and TVS. If perpendicular, then right angles. Let's go ahead and get them congruent so we don't forget. If right angles, then congruent. So I have one angle, and now y is angle W, or not W, y is angle Y congruent to angle T, right? If this is a parallelogram, aren't those opposite angles? Angle Y congruent to angle T. If parallelogram, then opposite angles congruent. So now those triangles are similar, YXS similar to TVS by angle-angle similarity. That's the easy part. Now we've got to get to these sides, right? Well, first I'm going to choose the ones from the triangle, right? So I'm going to start with this side right here, which I know I wanted. I wanted XS. So I'm going to look. XS corresponds to VS. Yep, VS is in that triangle. The other side of the triangle I want, I know, is this SY because it links up to something that I do need. So SY, and SY is first and last. First and last is TS, which I know is that other piece I need. So that is if triangles are similar, then the sides are proportional. All right. Now I'm going to cross multiply. So I'm going to have XS times TS equals SV or VS times SY. I simply say for that reason, cross multiply. But now notice we're close, but this guy's off and this guy's off. They're not the right ones. They're these yellow ones. But remember, they have links to these two. So I'm going to come over here. I'm going to remind myself that YS is actually congruent to WT. And I'm going to remind myself that ST, right, is linked to YW. Because if I have a parallelogram, then opposite sides are congruent. All right, so now you got to remember back how we use that substitution. YS is the same as WT. So can I take out YS and put in WT right here? And ST, this guy right here, is the same as YW. So can't I just put YW in here? So that's what I do in step 9. I leave XS. In place of TS or ST, I can put YW. I'm leaving SV. And then in place of SY, that's this guy right here, I can put WT. And I just call that substitution. So this encompassed two separate ideas. One, you have to take the ratio and multiply it out. And secondly, sometimes after you multiply it out, you may have to use congruences to replace certain pieces in there by substitution. That some of those pieces may not be pieces of the triangles, but may be linked to other pieces that you can replace. That's it for this lesson.